Hey everyone, welcome back. And in this lesson, we're going to start something that's sort of related to the last lesson. So the last lesson we talked about square roots and cube roots, what they are, and some of the squares or some of the perfect squares and square roots that you should kind of know. And in this lesson, what we're going to do is I'm going to break down how you can solve square roots by hand. Now, I'm going to be honest, I had to study up on how to actually do this because this is something that I haven't done in so long that I needed my own refresher, but this can be something useful for you to try. We'll just talk about a few somewhat simple cases, not like the simplest cases, so we're not going to calculate like the square root of 16 or something by hand, because that's something that that's one of the ones that it's just easier to memorize than to be able to calculate. But we'll do some slightly larger numbers that have slightly larger square roots. And so what we're going to do is, let me write down a title so you can write it down in your notes. Basically, we're just going to go over a few examples of how to solve, how to find the square root of a number by hand. So I'm not going to be able to fit this, am I? I'm going to have to put it down here. Solving square roots manually. So solving them by hand, no need of a calculator or anything like that. So what I'll do is, let me see, how do I want to do this? So what I'll do is I'll sort of talk you through the process, and maybe I'll make some notes where we have some space to make them. Obviously I'm a little bit limited space-wise, so I'm going to have to get rid of the title in a sec. But it is a bit of a multi-step process, and we'll start off by just talking about the simple-ish examples. This stuff does get a little bit more complicated, and perhaps if we have some time towards the end of this one, or perhaps the end of the next one, we'll talk about a slightly more complicated example, maybe dealing with a larger number. But for now, we'll do a decently simple case, and you'll see the sort of similarities in the things that we're doing here. So, so you'll see the similarities between the examples that we do here, and you might actually be able to relate it back to some of the things that we've done before, even though this isn't this isn't directly related to the things that we did, way back at the beginning of the term, but you might recognize some similar patterns just in the way that we solve the problem. So maybe that kind of thing will help you when you're trying to remember how this stuff works. So let's start off with, I'm going to erase this title, Solving Square Roots Manually, and I'm just going to throw it into the corner. Maybe I will throw it just onto this side over here. The question. So the question is, what's the square root of 256? Right? That's what we want to answer. We want to know what the square root of 256 is. Alright, so the first thing you're going to do is you're going to write exactly that number with that square root sign. Now that square root sign might look a little bit like a division sign. Some people, obviously, with division, they tend to write their division sign like that. I tend to write my division sign more like this. That's all personal preference, so if you don't like the way I write it, feel free to write it any way that works for you. But with the square root sign, I'm sure you've come across this symbol before. This is just the way that it's written. It looks kind of similar to our division sign, which actually works out for us because the similarities that you'll see between this and other stuff we've done mostly goes back to long division. So normally with long division, what we would do is we would deal with one digit at a time, right? We would have some divisor over here, and we'd see, can this divisor fit into 2? And if not, does it fit into 25? Deal with that, bring down just the next digit, and so on. With square roots, it's a little bit different. Ultimately, we are doing a division problem, I guess, but we don't know the divisor, which is a bit of a problem, right? If I told you you had a divisor of like 4 or 12 or something, then it's just a division problem. But we want to figure out a number such that if you were doing it as a long division problem, you had your 256 here, we're trying to find a divisor such that it's the same number over here and the same number as your answer. So you're trying to find a number that's both the divisor and the quotient when your dividend is 256. So the way we do that is using square roots. And the thing you have to do slightly differently with square roots is we're going to break off the number that we're dealing with into groups of 2 digits. So instead of dealing with each digit individually like we would in long division, we're going to deal with 2 digits at a time. And the way you're going to break it up is you're going to start from the right side and group the 2 digits on the right together. So we've got this 5 and 6 that are together, and we'll group them together by putting a comma in between the 5, 6 and this 2 over here. Now, if we had more digits past the 2, we'd put another comma there. So if you had a number like 1, 2, 3, 4, 5, 6, 7, and you wanted to take the square root of that, to break it up into groups, you'd put a comma there, a comma there, a comma there. And then you would leave, if you have 1 digit left over at the end, that's okay. We'll deal with that one individually, and then we'll deal with everything else in groups of 2, in pairs of digits. Alright, so if we were taking the square root of a larger number, you just start on that right side and then pair them off, pair them off, pair them off, and you might have 1 left over here, you might not, depending on the number that you're dealing with. So, with that said, now we've put our comma here, so we've separated this into 2 groups. We've got 56 over there, we've got a 5 and a 6, and we've got a 2 over here. So the first thing we want to do is we're going to deal with just this 2 right now. The same way with long division, if you're doing a problem where you're trying to do like a 84 divided by 2 or something, you don't look at the entire number, right? You look at just this divisor and just that first piece of your dividend, and you ignore everything else for starters. So we're going to do the same thing, and we're going to ignore that 5 and that 6. We're dealing with just the first group right now, which is only a 2. And so what we want to do is we want to find a number. So this is the part that's that you have to be careful with, is we want to find a number that if you square it, so if you multiply it by itself, it gives you an answer that's equal to this number or smaller than it. So again, if you take this analogy back to long division, if you had a problem like 84 divided by 2, you're only considering this 2 and this 8, right? So I wanted to find, in the case of long division, I wanted to find a number that I could multiply 2 by such that it's either equal to 8 or a little bit smaller than 8. But we don't want it to overshoot. We don't want 2 times something equals 9 or 10 or 11. That's too big. It has to be 2 times something equals 6 or 7 or 8, right? It has to be equal to the number that you're considering or a little bit under, right? So what we want to do up here, in this case, is we want to find a number that if you square it, you'll either get exactly 2, or you'll get a number smaller than 2. Now, if you remember some of our perfect squares, 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9. We're already way too big, right? We wanted a number that if you square it, mind you, it's a whole number. We want a whole number that if you square it, you'll get an answer that's equal to 2 or smaller than 2. 3 squared is too big, so that's out. 2 squared is too big, so that's out, which means we have to use 1 squared. So I'm going to put a little 1 over here, and I'm going to put a 1 up top. Okay, just like with long division, when you get that number that you're looking for, you throw it up top. So we've got that 1 up top. This one over here, we'll see it pop up in most of our questions, but it'll change a little bit later on, so don't stress too much about this guy over here, at least not for the time being, but make sure you get that 1 up there. Alright, now, just like in long division, once you've got your divisor, you've got that number up there, in order to figure out what we're subtracting, we have to compute the product of those two things, right? So, so that's what we're going to multiply together, is that, again, if we go back to our analogy of a division problem, if you had something like 84 divided by 2, then you figure out, okay, 2 goes into 8 4 times, and then to figure out what you're subtracting over here, you have to do 2 times 4, which is 8, and then do that subtraction. So you're going to make use of the number that you just wrote up top in order to actually proceed towards the next step, which is that subtraction. So, so to do that subtraction, we're going to take this one over here on the side, and that one up there, and we're going to multiply those two together. We're going to multiply those together. So multiplying those together, we get 1 times 1, which is equal to 1. So I'm going to put that down here, and we're going to subtract. Alright, simple enough. We're just dealing with that 2 right now. So 2 minus 1 is going to leave me with 1. This part, hopefully you're seeing, is kind of similar to long division, right? So once you've got that number up top, the only difference really is that we're not trying to ask ourselves, we are in a way asking ourselves, what do we multiply this divisor by? But really what we're asking ourselves here that's different from what we were doing with division is, what number can I square and get an answer that's 2 or smaller? So that's the slight difference, but you should hopefully notice a bit of a similarity after that once you've got that number up there, you do a little multiplication, bring it over here, do a little subtraction, and you're left with this number down here. Now, if this was a division problem, we would only bring down the 5, right? And we would turn this into a 15. But because we paired off the numbers in groups of 2, we're going to keep that group together. So because the 5 and the 6 were paired off into the same group, we're going to bring both of them down at the same time. Alright, so instead of bringing down just the 5 and having 15, we're going to bring down the 6 as well, and we're going to get 156 instead, right? If this happened to be something minus whatever is equal to 0, then we would just bring down both of those, we'd be left with just a 56. But because we've got 2 minus 1, we've got this 1 left over from our subtraction, and then you bring down the next 2 digits just as we would in division, but we're bringing down 2 digits instead of 1. Now, this is sort of the confusing part. So, now, we're going to take this digit up top, that 1 right there, okay? We're going to bring it over here, but as we're bringing it over here, we're going to multiply it by 2. We're going to double it, okay? So whatever your answer is up there, sometimes it'll be a 1, sometimes it won't. As you bring it down here, you're going to double it, no matter what it is, okay? As long as we're dealing with square roots, you're going to double it. So you double it, and we're going to, okay, we got 1 times 2 is 2. Be careful, don't write that 2 down just yet. This 2 is not our new divisor just yet. This 2 is part of our new divisor. The way your divisor works is the 2 is actually going to sit, instead of being the entire divisor, the 2 is in the tens place of your divisor. That is, it's going to be 20 something. This could be 20, could be 21, 22, 23, all the way up to 29. It's going to be a 2 in the tens place, and then some digit over here. And so our next step is to figure out what this digit over here is. Alright, we'll see this again with another example after this. But, so, this is the part you have to remember, is that as you bring that digit down, the digit that you just had up there, as you bring that down, you double it, but you also have to add that space to the side of it. If you were bringing down 2 digits, which we'll eventually get to, if you were bringing down 2 digits, then they would occupy the hundreds place and the tens place, and then you'd still have that gap for the ones place. So every time you bring this down and double it, you're going to add that extra space over there on the side, and we need to fill in that space right there with some sort of number. And it could be anywhere from 0 through 9. We have to figure out which one it is. So, let's do that then. Now, to figure out that number, this is possibly the most complicated part of the problem, is we need to find a number that, if you put that number down here, so just, let's say for example it was 7. Don't write this down, not yet. Let's say it was 7. If you put a 7 down here, we want a number such that if you took this, if you put that number over there, 27, and then you multiplied it by that number that you just wrote down, that 7 over there. So you had 20 something times whatever that something is. So if you're writing a 7 here, you're writing a 7 here, and you're computing 27 times 7. Alright, this is the part that's tricky, is whatever number you write down here, you're also going to multiply this entire thing by in the next step. So what we need to figure out is, we need to find a number such that if you made it 20, let's say 23, and then you multiplied it by that number that you just wrote down, that 3, it would equal 156, or be as close as you can get to 156. So like with our division problems again, we're trying to find some product, one number times another number, that's either equal to what we have here or a little bit smaller than what we have here, right? As close as we can get to 156 or 156 exactly. That's the target. Now, the struggle is figuring out what that number in there is, because it's not as simple as, oh, it's going to be 27 times 27. We're not squaring this number. That would be different. That's only done in this first step up here. We're not squaring this entire thing. We're not squaring 27. We're not squaring just a 7 if our answer happened to be a 7. What we want to do is basically the way you want to test this out is, so we know it's going to be 20-something times whatever that something is. So for example, if it was 20, the something that we're filling into this space would be a 0. So it would be 20 times 0, which equals 0, right? If it wasn't a 0, we want to fill in this number with something that we're also going to multiply the new number by. Let's say it was 21. Then your something is that 1. So you're going to multiply 21 by 1, which would give us 21. Alright, hopefully you'll see the pattern. I'm going to keep writing these out, but hopefully you'll see the pattern as we progress down this list. If you made it 22, you have to multiply by that number that you just wrote in the ones place, which is a 2. So we would do 22 times 2, which is going to give us 44. Right? If it was 23, then the number that we just put in the ones place would be a 3, so we have to multiply this whole thing, this 23, by 3, which would give us 69. Alright, we're going to have to keep going. I'm going to have to, I can squeeze them in here for the time being at least. If the something happened to be a 4, that it's 24, then we're going to multiply this whole 24 by the number in the ones place that we just wrote down, which is a 4. So we would do that, we would get 24 times 4 should be 96. Alright, so basically what we're trying to do, we're trying to find a number that if you fill it in this ones place, that space beside the 2, and then multiplied the 20 whatever by the number that you filled in the ones place, you get to 156 or smaller. So we want our answer over here to exactly equal 156, or to be the last possible answer you can get before you overshoot 156. So if we keep this going, right now 96 is too small, so let's go up one more. So instead of 24, we'll do 25. The number that we filled in the ones place here is a 5, so we're going to multiply the whole thing by 5. That's going to give us 125. Alright, now I'm running out of space. I'm going to get rid of the 20 times 0 up here, and the 20 times 1, just so we have some space. So the next thing we want to do is we'll go up one more. We'll do 26. Now the number that we've filled into that gap is a 6, so we're going to multiply the whole thing by 6. And if you go ahead and do that calculation, you get 26 times 6. 6 times 6 is 36. 6 times 2 is 12, plus 3 is 15. Aha! That gives us 156 exactly, right? Which is our target number over here. We wanted a number that we could fill in beside that 2 to make it 20-something times something equals 156. So we got 26 times 6 equals 156 exactly. And if it happened to be off by a little bit, if our target number was 157, let's say, then we would go on to the next step. We'd do 27 times 7, and we would calculate that one, and we'd see, oh, this one overshoots, so we have to backtrack to the 26 times 6, because 27 times 7 would be too big. But in this case, everything works out, because it gives us 156 exactly. So what's so special about this thing equaling 156? What on earth am I supposed to do with the information that, okay, I've figured out it's supposed to be a 6 here and a 6 somewhere else? So the way it works is, up here we basically had an empty ones place, and we were asking ourselves, what can I put here and there that when I multiply it together it's going to give me 2 or smaller? And the answer there had to be a 1. Now down here it's going to be 20-something times something. So what we're going to do is we're going to take that 6, and that's building our 26, and we're going to throw it into that space beside the 2. So now we've got a 26 over here. And what about this 6 over there? Well, if you look at what we did in our first step, we had one number over here and one number up top. And similarly with division, every time you're dealing with a new thing, the answer that you get, you throw it up top. So we're going to take this 6 over here and throw that upstairs. And we're going to throw it above the, I guess, the last digit of the group that you're dealing with. It's probably just easiest if you do it that way. I know it looks a little bit weird that we've got such a big gap here, but that's just the way it is. Notation-wise, I guess it's just the cleanest to do it this way. So just, if you have two numbers in the group that you're working with, just put this digit over here above the rightmost of those two numbers. So we're going to have that little gap there, but don't worry too much about it. Alright, so now here's the 26, right? I don't know what shape I was trying to draw. I couldn't decide between a box and a circle. So here's the 26 that we just got, and then there's the 6 that we just got. Right, so we're going to multiply those together, because remember back here we took these two digits, we multiplied them, or we took these two numbers, 1 and 1, multiplied them together to get 1, which we then subtracted and moved on to the next step. Now we're taking this 26 over here, and that 6 over there, and we're going to multiply those together, which, as we just figured out, is 156. 26 times 6 is 156. We'll throw that down here and subtract. Similar to long division. Every time you compute one of those products, you write it down here and you subtract. And if we go ahead and we subtract 156 minus 156, we'll be left with 0. Alright, we'll be left with exactly 0. If you get 0, you're done. We'll come back to problems, perhaps at some point. We'll see how we're doing time-wise, I guess. But we'll try and come back to problems where you don't finish with just a 0 over here. But for the time being, we're only going to do examples that end with this nice clean 0 as your last line so that you don't have to worry about anything else. Just like a division problem, once you get to that 0 at the bottom and you've run out of digits to pull down, you're done. So where is our answer, right? If you remember in our division questions, the answer isn't that thing that you get at the bottom. The answer isn't anything that's over here on the side. That 1 isn't helpful. This 26 maybe, but no, the 26 isn't helpful, the 1 isn't helpful. In a division problem, our answer is what we write up at the top. And so it's the same thing with square roots. Our answer is this thing up top, which I know it looks a little bit weird because there's a gap there in between the two numbers, but our answer is that 16 that we had right there. We got this 1 from our first step and then this 6 from our second step. So our final answer for the square root of 256 is what we have up there, which is 16. Alright, so, and you can always go back and check that. If you're not sure if you've got the right answer, go through and calculate 16 times 16 on a calculator or on paper and see if it gives you the same answer. See if it gives you 256, what you started with. Right? The same way we can check a division problem is multiply your divisor by your quotient and see if it gives you back your dividend. Same idea. Take your final answer here and square it. Multiply it by itself, and see if it spits out the number that you started with. Alright, hopefully that's making sense. So what we've got there is, do I want to do another example? Yeah, let's do another example. This one I'll have to go a little bit quicker just because, we're already clocking up 24 minutes over here. But hopefully that's making sense. This one I'll do a little bit faster, I guess. I'll try not to go too much faster. I know there are a lot of steps to this. It's a new concept. It's got some confusing steps that we're not really used to. But I'll go through one example perhaps a little bit more quickly than I would like to right now. But then in the next video we'll come back, we'll do some more examples. I'll try and do one more now, and then I'll try and do 3 in the next video so you can sort of see that pattern as we go. Alright, so in our next problem, we're going to try and figure out the square root of 361. Alright, that's our new target, square root of 361. That's what we want to figure out. So, we're going to write down our square root sign, and we'll write down our 361. And we want to separate this into groups. So, we want to separate it into groups starting from the right, and we're going to just put a comma every 2 digits. So starting from the right, we've got that 6-1 as a group. We put a comma here. We're left over with a 3. We don't have anything else over on this side, so we don't need to put any more commas. So we're done there. So now we're going to deal with our first group, which is just this 3, right? And basically, the way we were doing it before is I'd put a 1 here, and I said don't worry about the 1. But then if you remember in our second step, we had that 20-something, right? We had an empty ones place, and then we were multiplying it by the very same something that we'd started with, right? Or that we were plugging in here, we plug it in over there as well. So if you don't like me just plonking down a 1, then think of it as an empty ones place. All right, so think of it as an empty ones place, and whatever number you put here, you're also going to put up in that space over there. All right, that looks like a 0, so I'm going to get rid of that and put this little underscore-y type thing. So basically, we want a number that if you put it here and you put it up there and you multiply those two together, now in this case, because it would just be one number times itself, we are effectively squaring it. In the next step, you might have a 2 or a 3 or something kicking about in front, which is why you're no longer just straight up squaring the number. It's going to be something times something, where the ones place of those two numbers is the same, but the tens place doesn't have to be. Now in this first step, by default, there are no digits there, so it's an empty ones place times what's going to become itself. Or the other way you can ask yourself that question is, instead of plonking down a 1 here, or instead of thinking of it as an empty ones place that you need to fill in, just ask yourself, look at this first group, we're dealing with a 3, what number can I square to get exactly 3 or smaller than 3? That's the target. What number can I square? 1 squared would give us 1. 2 squared would give us 4, which is already too big, right? You could keep going and write down a few. 3 squared is 9, 4 squared is 16, but we already know 2 squared is too big, 3 squared is too big, 4 squared is too big, so it's going to have to be 1. If you think of it in terms of an empty ones place every time you have to go through this step, then we're filling in a 1 over here, and we're filling in a 1 up there. Alright, I don't want those to look like 7s. So we've put a 1 here, we've put a 1 there. Alright? And we're going to multiply those two together. So we're going to take this 1 on the side, multiply it by that 1 on top, and that's going to give us, obviously, 1 times 1 equals 1. So we put that 1 down here, and we subtract. That's going to leave us with 3 minus 1 is 2. So we can go ahead and bring down our next group of 2 digits, our next pair of digits, which is going to, in this case, be the 6 and the 1. So remember, you have to bring down 2 every time. So we've got a 6 and a 1. So first we were dealing with 361. We broke it into groups. We've dealt with the 3, and now we're dealing with 261. That's our new target. But we got to take the number that we have up top, which is that 1, and we're going to bring it down over here. We're going to double it as we go. So now we're going to have a 2 here, and then an empty ones place. So every time you go through this process, if you have another number there and more things to bring down, you'd bring the whole thing down, double it, and make sure you tack on that empty ones place. So just take whatever digits you get after doubling up there, and then just shift them over. Just shift them over a spot so that you have an empty ones place. So now what we want to find is, just like before, we want to find a number that if it's 20-something times the same something, so whatever number you put in this place, you also put in that place, we want it to equal 261 or be a little bit smaller than 261. So this symbol here, that's less than or equal to. So we want it to be either smaller than 261 by a little bit or exactly equal to 261. So let's just eyeball it. Let's take a guess. Let's try 5. Let's try 5. So we've got 2 blank times blank. So it's 20-something times something. And let's try throwing in a 5 there. So if we throw in a 5 and a 5, that'll give us 25 times 5, which should be 125. 5 times 5 is 25, 5 times 2 is 10, plus 2 is 12. That's going to give us 125. Too small. Right, we want 20-something times something. That's going to get us really close to 261, and 125 is kind of far. We're not even halfway there yet. So let's go bigger. Let's do 7. Let's try 7. So let's do 25 times, what am I saying? Not 25. It's going to be 20 blank times blank. So here it's going to be 27 times 7. That's what we want to calculate next. So let's go ahead and figure out that. and see if 27 times 7 overshoots 261, is exactly 261, or is a little bit smaller. 7 times 7 is 49, carry the 4. 7 times 2 is 14, plus 4 is 18. That's going to give us 189, which is better, but still not close enough, right? Let's try going bigger. We could do 28 times 8, but the reason I don't want to do that is because I know if I have two numbers ending in 8s, and I multiply those together, we know 8 squared, or 8 times 8, is 64. So my final answer is going to end in a 4. But if I took 9 and squared it, if I did 9 times 9, I'm going to get 81, which means my final digit of 29 times 9 in this case has to be a 1. And since we have a 1 over there, I'm tempted to try that one first instead, even though it's a bit of a jump, because 29 times 9 is the largest thing we can do, right? We can't do 30 times 10 or anything like that, because we know this number has to be in the 20s. It's got to be 20 something, so the highest we can go is 29 times 9. So let's do 29 times 9 and see if it gives us 261, or maybe it'll overshoot a little bit. Let's find out. So it's going to be 20 blank times blank. We're filling in a 9 in both of those spots, and let's see what that gives us. We've got 29 times 9. 9 times 9 is 81. There's the 1 that we're looking for. 9 times 2 is 18, plus 8 is 26. Aha! That's the 261 that we were looking for. So, we know that our magic number is 9. The number that gives us exactly this number, or gets us really close to it. In this case, it got us exactly that number. So 9 is our magic number, so that means we're going to fill in a 9 over here. I'm going to get rid of that space. And we're going to fill in a 9 up top, above our group for the 6 and the 1. We're going to throw a 9 up there. Now, what do I subtract? I'm going to take those two numbers that I just built by putting in the 9. So we've got this 29 over here, and we've got that 9 up there. We're going to multiply those together. So we've got 29 times 9, which, as we just calculated, is 261. So that's what I'm going to go ahead and subtract down here. So it's 261 minus 261 is going to leave me with 0. Alright, and because we've got a 0 down there, and we've got nothing else that we can bring down from over here, we're all done. And we just need to read off our answer, which in this case isn't complicated because we got a nice clean 0 at the bottom, which means that we've dealt with everything exactly. There's no remainders left over, there's no decimals, no nothing like that. We're just going to read off our final answer from the top up here, which is that 1 and that 9. So we just take those together, we ignore that there's a funny gap in the middle, and we've got our final answer, which is 19. And you could go ahead and, if you're not sure if that's the right answer, go ahead and do it. Go ahead and calculate 19 times 19, or 19 squared. Punch it into a calculator, or do it by hand, and it should give you 361. Alright, now obviously I've been picking questions so far that are going to give you those nice clean answers. In the next, possibly in the next video, all the examples that I'd sort of sketched out for that one also give us nice clean answers. Perhaps we'll explore some that don't, but maybe we'll just try and keep this simple, because this is a bit of a weird process with this whole, moving your thing over to the tens place and doubling it. It's a bit of a messy process, so maybe we'll just sort of stick to a few basic examples so you get the idea, and then on your assignment and maybe on your test, there'll be one where it's just, again, one of these clean, simple examples, no decimals, no funny business with like a remainder or anything like that. Just, you find a square root and it's exactly the square root. There's no decimal, there's no remainder down here. You should get a 0 in your answer down there, or a 0 in your remainder down there, and some nice whole number up top. No funny business there. But yeah, hopefully you're getting a bit of a feel for how this stuff works. Next time out we'll do, I'm hoping, 3 practice problems. We can go a little bit faster than we did today. Yeah, if this isn't making sense, my apologies. I was revising this in the last couple of days to make sure I knew it well enough to actually show you guys without confusing you entirely. So hopefully I haven't confused you entirely. Yeah, if you guys have any questions, get in touch with me. Otherwise, I will see you in the next video. Have a good one.